Hi, my name is Seth Bogle. I'm a remote sensing analyst and also an on-site contractor with the USDA Forest Service's Geospatial Technology and Application Center, or GTAC, in Salt Lake City. And today I'm going to be talking to you about monitoring trends in burn severity, or MTBS, and specifically about available data and tools. I'm not entirely certain with everyone's familiarity with the program, so I wanted to begin by discussing some of MTBS's background. The objective of the Monitoring Trends in Burn Severity program, or MTBS, the acronym that I stated before and will continue to use throughout this presentation, is to assess the frequency, extent, and magnitude in both size and severity of all large wildland fires in the conterminous United States, Alaska, Hawaii, and Puerto Rico for the period of 1984 through 2020 and beyond. This includes both wildfire and prescribed fire. So what do I mean by large fire? For the purpose of MTBS, we have defined large as all fires reported greater than 1,000 acres in the western U.S. and greater than 500 acres in the eastern U.S. This map here illustrates that east-west breakpoint used by MTBS. All fires that meet this criteria, regardless of land ownerships, are assessed. So what is gained by using that east-west break? What does MTBS currently map? We estimate that MTBS currently assesses about 5% of U.S. fire occurrences. Those account for about 95% of U.S. burned area each year. But what about the smaller fires, you may ask? The issue of ignoring smaller fires could very well equate to hundreds of thousands of fires and about 5 million acres going unassessed. But if you think of the converse of what is shown on this slide, working those other fires would result in 95% more individual events being assessed, but would only produce about 5% more area being captured. So we think we've struck a good balance here. The initial phase of MTBS was completed between 2005 and 2012. Its goal was to assess fires that had burned between 1984 and 2010. Ever since then, MTBS has had funding extended each year to include subsequent years. The MTBS program is conducted jointly between the USDA Forest Service at GTAC in Salt Lake City and the USGS Aero Center in Sioux Falls, South Dakota. On a typical day, between 6 and 8 people are in some way involved with MTBS between these two centers, either through mapping, database management, website maintenance and support, or responding to help desk questions. The MTBS program meets the needs of two policy initiatives or mandates. It was originally chartered by the Wildland Fire Leadership Council, or WFLC. WFLC's monitoring requirements are used to assess the effectiveness of national fire policy. That's the reason why MTBS data is compiled for analysis at a range of spatial, temporal, and thematic scales and are intended to meet these particular information needs, as well as a variety of information needs that require consistent data about fire effects through space and time. Additionally, the Government Accounting Office, or GAO, found that the Department of the Interior and Forest Service did not consistently provide post-fire information that characterized fire effects across the landscape. Agencies provided inconsistent data or no data at all for some fires, such as providing perimeters only. Therefore, the GAO recommended the development of a comprehensive interagency methodology to consistently map and assess the effects of fire across the landscape and ecosystems, to improve land management practices in the context of fire disturbances. Let's now talk about the MTBS data products. At the present time, 1984 through 2019 is complete and 2020 mapping is underway. This constitutes over 26,000 fires which are available for download from mtbs.gov. You can see the spatial distribution of the fire centroids in the graphic here. This is the 26,000. The reason for the asterisk on the 2019 is that 2019 fires from the Dakotas down to Texas and east have been mapped, but they are just now undergoing a QA/QC process before public release. Everything west of there for 2019 is already available for download. The individual MTBS assessments produce a suite of geospatial data products, both in raster and vector formats for each of those 26,000 individual fires I was previously mentioning. And they're each bundled into single compressed archive files. All data sets are projected into Albers equal area using appropriate regional projection parameters. All the raster data, or the imagery rather, is at 30-meter spatial resolution and are subset to the extent of the burned area boundary plus 3 kilometers for a buffer. Product descriptions and all data processing procedures are documented in associated metadata available on the MTBS website. Here you can see both a list and examples of what data is included with the individual bundles. The individual vector data sets or shapefiles included within the bundles contain a multitude of attributes related both to the fire itself and the analyst's assessment of that fire. Some of those include, of course, the name of the incident, the ignition date, and identifying information for the imagery used in the assessment. These data products are also aggregated and provided as national or regional data sets. One of those data sets are the centroids of the burn area boundaries. This point feature shapefile also contains all of the attributes listed from the previous slide. Additionally, we also aggregate the individual burn area boundaries into one polygon feature shapefile. Both the national point and polygon shapefiles have been reprojected into North American Datum, or NAD 1983. Lastly, since the thresholded burn severity products are much larger in size, a mosaic geotiff for each individual year is available for download. These products are kept in their regional projections, which depending on the fire year could mean up to 4 individual mosaics per year, one each for the conterminous United States, Alaska, Hawaii, and Puerto Rico. Let's take a look at how we can access the MTBS data. This is a screen capture of the interactive viewer available at mtbs.gov. In this graphic, I have adjusted the parameters at the top of the window to show me all available MTBS data for 1984 through 2019. By clicking the arrow at the bottom right, a window with all the individual fire bundles becomes visible, as we can see here. While this, of course, isn't the best way to look for data on a particular fire, it somewhat illustrates how to use the utility. Adjusting the parameters across the top of the screen and redrawing a bounding box will get you to the level of detail needed to make an appropriate selection. Now here we can see I've narrowed my focus both spatially and temporally. Individual bundles or groups of bundles can be selected or deselected through the check boxes to their left before a download button becomes available. By clicking the download button, it directs the downloads to a storage location of your choice. Here we're looking at the direct download options available at mtbs.gov. On this page we have the option to download the national point and polygon datasets, as you can see on the lower left, and we also have the option to select from the available regional mosaic datasets that I had mentioned earlier. What I have shown here are just 2 facets of the mtbs.gov website. On the site you can find more information including product descriptions, frequently asked questions, links to research citing MTBS data, and a link to a glossary of common terms. The glossary actually links to this website, the Burn Severity portal. I like to think of this as a sister site to mtbs.gov. Its purpose is to provide user downloadable data for other burn severity mapping programs in addition to MTBS. Here you will find descriptions to these other programs as well as information and graphics on how they relate to one another. You'll also find an interactive viewer to download data very similar to what we just saw at mtbs.gov. This screen capture is the description page for MTBS with information about the program, links to the data, as well as a link back to mtbs.gov. Similarly to mtbs.gov, you can find frequently asked questions, links to research, and of course, the glossary of common terms. This is a screen capture of the new MTBS Data Explorer. In the past, the MTBS data bundles contained information about how fire severity interacted with other land areas such as watersheds and ecoregions. This data was made available tabularly through what was known as reporting data. Unfortunately, these data were also static and didn't always meet the needs of the user. Not to mention, you had to compile various tables if you wanted to study an area larger than just a single fire. For those reasons, we decided to go another route. These tables are no longer produced. So now, instead of those tables, this portal allows a user to create their own queries. Some queries worth mentioning are fire occurrences over time across a state, burn severity by an LCD vegetation class, or percent burned area within, say, an ecoregion. There are many more options available in the tools section of the left pane seen here, but I think the most utility comes from the user being able to upload their own area of interest with all the data available and ready to go. No desktop GIS required. We've also been working to create several tools within Google Earth Engine. Some of these tools are used by current mapping analysts to assist in creating actual MTBS data products. Other tools we have are used to help forests and agencies create what we like to say is an MTBS-like product for incidents that might not meet the current MTBS criteria, such as size. This screen capture shows what we call the Landsat and Sentinel-2 viewer. It's a tool designed to help an MTBS analyst quickly identify imagery suitable for creating a mapping. In addition to being used to identify cloud-free imagery, the tool is also able to calculate both a DNBR and DNBR offset on the fly. The DNBR offset is something that's used to determine how well an image pair matches phenologically. Lastly, I just want to say that we recently started working with Google to have the MTBS burn area boundaries and the burn severity mosaics added as official Earth Engine assets that can be accessed publicly. What I just said might have been gibberish to some, but for those of you familiar with Google Earth Engine, you probably understand why that makes me really excited that we're having that underway. Finally, let's take a look at a couple of very simple ways we can use MTBS data. As a whole, the MTBS data record can be used to analyze trends over both large and small areas. Graphs similar to this can be created using the MTBS Data Explorer. In fact, that is exactly where this data came from. The MTBS Data Explorer output showed the data broken into all 6 available burn severity classes. I took that data and then simply aggregated it into the 2 classes you see here. Percentage of moderate and high severity by year in red, and percentage of unburned and low severity in gray. I've also overlaid the number of incidents per year across the yellow line that you see here. This is not the entire MTBS data record. Here I have confined my analysis to just the southwestern United States for 1984 through 2019. In addition to aggregating the data and looking at it tabularly, the data can of course also be used spatially. And that can be done individually, fire by fire, or it can be done in conjunction with data from adjacent fires. In this example, I'd like to show how the data could be used to potentially predict a fire's extent. In this borrowed graphic from the former GIS coordinator at Grand Canyon National Park, we see 2 adjacent burn severity layers and a 3rd burned area boundary. The burn severity layer in the center is the 2001 Vista fire, and the one up and to the right is the 2007 Neck fire. The teal burn area boundary is from the 2009 Aspen fire. As you can see, the Aspen fire had little difficulty extending itself through the lower severity areas of the Vista fire, but appears to have stopped just at the edge of the higher severity areas within the Neck fire. While both this and the previous graph have been fairly simple and straightforward examples, I hope they convey some of the utility that can be found within MTBS data. Thank you for your time. I really appreciate the opportunity to share MTBS with you today. Again, my name is Seth Bogle. Please don't hesitate to reach out with any questions you might have. My contact information can be found right here.